Hello everyone, welcome back. In last video I have explained about different types of friction, and during different types of driving patterns how different kinds of frictions will influence in your day-to-day life, right? Now in this video I am going to explain about different types of surfaces and what kind of friction that is available on different surfaces, that I am going to explain. Have you ever wondered your tire grip changes every second depending on the road surface, like dry asphalt or wet roads or sand or mud? So your surface behavior will change differently based on the surface. Your tire grip changes every second during on the road. That you know that dry asphalt is having different friction, like wet road on dry asphalt, if it is raining, you have different kind of mu value, like friction value. At the same time, if you are driving on a sand and mud, you will be having different type of friction that is available. So each surface behaves differently, and if you don't know how the grip changes, even a small mistake can lead to a crash. It can lead to a fatal crash. Now I'm going to quickly explain about different types of surfaces, and I'll make you understand the effect of surface and the friction value, especially when you are driving. I'm going to explain about three major surfaces that you encounter in your day-to-day life. Okay, first thing which I'm going to talk about is dry asphalt. In dry asphalt, the friction value available is, like, the coefficient of friction available is around 0.8 to 0.9. This is the best and the maximum friction that you can get. So on this surface, the interlocking nature between your tire and the surface will be at the highest point. So you'll get the maximum friction that is available on the dry asphalt. On this surface, you'll get the highest static friction, and at the same time you'll get a little bit of rolling friction and little bit of static friction. Static friction is almost negligible if you don't having any wheel spin. So the major contribution is coming from static friction. Like 80 to 90% of your static friction will keep your vehicle stable and keep your drive safe. Similarly, and you'll have maybe 2 to 4% of rolling friction, and like remaining other like 3 to 4% or 4 to 6% of sliding friction will be available, especially on the dry asphalt. So this dry asphalt is always predictable, so it will give some kind of confidence to you, because you will get the maximum performance on that surface. You don't have to worry about anything. So you will get the maximum performance on the dry asphalt. This dry asphalt is best for your braking and cornering. Talking about the static friction and rolling friction and kinetic friction, you can check out my previous video. I'm leaving the link in the above card. Now take an example. Now let's say I'm taking a vehicle or a driver with a bike of 150 kg. Now I'm converting this 150 kg into Newton in order to find out what is the normal reaction acting on my tire with respect to surface. Okay, then if I'll convert it into Newton, I'll be getting around 1500 Newton, because I'm roughly taking G value as 10 meters per second square. Okay, for the dry asphalt, if I'll consider 0.8 is the new value that is available, so if I multiply this 0.8 into 1500, it will accounts to 1200. So 1200 newtons is the maximum frictional force that is available for you on the dry asphalt. That means, so similarly, meaning up to 1200 newtons of braking or acceleration for you, braking or accelerational force is available for you. So that much of force you can utilize it from your bike. Okay, beyond this the tire will, if you go beyond this, the tire will starts to slip, or it will go to sliding friction. So now for the second surface, like I am considering wet asphalt, it's like a medium grip. Okay, here your frictional value will be between 0.5 to 0.6. And now I'm taking the same rider and bike as an example. Let's say 150 kg as the weight. Now I'm considering again same conversion I'm doing, converting it into newtons. Now the coefficient of friction that is available on wet asphalt is like 0.6. Okay, so what is the formula that I have told you? F is equal to mu into n, right? So if I multiply this 0.6 into the normal reactional force that is available, which is 1500 Newton, I will be roughly getting around 900 Newton. So in the dry asphalt, the maximum frictional force that is available is 1200 newtons. Okay, whereas if you comes to wet asphalt, the frictional force is reduced to 900 newtons. Why this is happening? In the wet asphalt, water forms, like whenever it is raining, right? Whenever it is raining or is there any water is there on the surface, on the dry asphalt, your water forms a film on the surface of the dry asphalt. So which reduces, like this film act as a coating in between your tire and the surface or the road surface. So water forms a film on the surface which reduces this interlocking behavior between your tire and molecules. In the dry asphalt scenario, or in the normal dry surface scenario, the interlocking between your surfaces is very high. On this surface, the interlocking nature is very high. Whereas if you come to wet asphalt, your interlocking behavior between the molecules will reduce significantly. So that's why in wet asphalt, if you see static friction you utilize is around 70 to 80%. Whereas if you come to wet asphalt, your static friction will reduces by 50 to 60% because of the water film on the surface, and which reduces the interlocking between your tire and the surface. Similarly, your sliding friction contribution will increase. The sliding friction contribution will be increased more than 20% or 30%. That's why your wheel lock easily, or wheel slips or wheel skids easily when you are going on any wet surface especially. Okay, the point that you have to consider, why I'm saying this surface, why I'm trying to bring this surface awareness, is because I have seen many people that they go driving on roads, they will go on the same speed even though if it is raining or even the surface is wet. So the amount of stopping distance will significantly doubles. Okay, so let's say your vehicle has a capability to produce 8 meters per second square. So your vehicle has a capability to produce 8 meters per second square of deceleration. Let's say from point A you have to start braking, and till point B you have to stop. Let's say that distance as X. Your vehicle has a capability to stop within that X if your surface is dry. Okay, if your surface is wet, the same stopping distance will increases by 2 times. Instead of X, your stopping distance will going to increase by 2x. That's why your wheel slip becomes unpredictable, especially on the wet surfaces. So when your surface is wet and when your wheel is skidding, that's where your ABS and other safety functions will come into picture. What I'm saying is, so your static friction is always plays a crucial role, which gives you the maximum confidence, like where you have to brake or if you want to accelerate. That is the maximum amount of friction that you can utilize. If your static friction contribution is reducing and if your sliding friction contribution is increasing, that's where you have to be very careful, especially when you're driving. Okay, now you have seen the same bike and same road has given you different frictional force values. In dry asphalt you have got 1200 newtons, whereas in wet asphalt you have got 900 newtons, like which is the maximum friction that you can utilize. Okay, now same scenario for the third surface, I'm going to consider around sand. Now for this sand, the coefficient of friction available will be very less. It might be go to around 0.3 or 0.4. Okay, when this coefficient of friction value significantly reduces, what happens is that your wheel skid or wheel locking pattern becomes very unpredictable. Okay, why I'm considering this sand and mud? Because in your day-to-day life you can easily encounter these kind of surfaces. So especially when these sand or mud surfaces are there, the interlocking behavior of the molecules will be completely eliminated, because the sand molecules are mud particles. They will form a like roller kind of surface, like it's like you are going on a skateboard. So if I put a skateboard, like when you're walking, what happens? You'll slide, right? Similarly, that the same phenomena is going to happen between your tire and the surface. There is no solid surface available for the tire to grip at that point of time. On this type of surface, especially on this kind of surfaces, always your sliding friction will come into picture very easily. So let's say you're in dry asphalt, your static friction is up to 75% or 80%. In this kind of sand surfaces or mud surfaces, your sliding friction contribution is significantly increases to 40% or 50%. That means static friction only contributes 40 to 50%. Then again the sliding friction contribution will be increased significantly. That's why you cannot understand the transition. Like when you are transitioning from that that static friction to sliding friction, if you are not able to understand that transition easily, your wheel is going to lock at that point of time. So especially in these kind of scenarios, your safety functions will come into picture. Now let's assume your mu value is 0.4 because of the sand or mud, and if I use the same 1500 Newton which I have considered in the earlier example, like same bike and same rider, which leads to 1500 Newton, that 1500 Newton, if I multiply it with 0.3 or 0.4, let's say I will consider it a 0.3, you will get only 450 Newton of frictional force that you can utilize. So if I'll reduce this value, let's say 0.3 to 0.2, if I reduce, you'll be having only 300 Newtons of frictional force. So the amount of frictional force that is available is significantly reducing. So static friction, if you have 300 Newtons in the sand or mud surface, the sliding friction, you will be having only 225 Newtons. So same formula if I use, right? So the amount of transition, if you see some 300 Newtons to 225 Newton, the amount of difference is very less. So same bike, same speed, dry road can handle up to 1200 Newton, whereas your wet asphalt or wet surface will handle up to only 600 Newton or 900 Newton, right? If you go to sand or mud, you will be handling only 300 Newton, that is only available for your grip. So the main points to consider whenever you are driving on a wet surface, always be aware of the surface. First thing, always be aware of the surface. Okay. Second thing, reduce your speed. If surface is wet, reduce your speed by 30 to 40% always. Especially on sand or mud surfaces, you have to significantly reduce it by 40 to 50%. Okay. If your vehicle has safety systems like ABS, okay, then these functions will help you in this kind of aspects. But if your vehicle doesn't have this kind of safety functions, always learn to brake progressively. Okay, if you're learning to brake progressively on different surfaces, keep practicing it. So if you're learning to brake progressively on different surfaces, you'll get that eventually. Okay, learn to brake, always learn to brake progressively based on the surface. Okay, that's it all for this video. You can check out my previous videos to understand about static friction and kinetic friction, how it works in different driving patterns. And this video will give you the awareness on different surfaces and how it is useful for you in your day-to-day life.